Hi, good afternoon, everyone, and welcome to GlobusWorld. It's fantastic to see so many of you here in person. I think since the pandemic, full house GlobusWorld a while, so it's really great, and we are grateful all of you taking the time, traveling out here and spending the week. I hope you find the meeting productive and useful. We are very much energized and looking forward to it. So the Globus product as we know it today, platform as a service and software as a service, this is going to be year 14. It was reached 14 years ago when we took this hybrid model. Very much we're focused on data, but since then it's expanded out to doing compute and automate. But we sort of use that hybrid model all through. So in this case, the institution manages and operates the resources. So it used to be storage systems, compute resources, we have instruments that have come in, other services that they operate and run, everything that is managed by the institution, whether it's on-prem or cloud. And then we distribute these agents that allow them to connect these resources into the Globus ecosystem. These agents have a gateway, we have allowed this to scale. And they have a different flavor. You have a data-based one for compute, and each of them also has plugins to support a variety of flavors within that, different types of storage system, different types of compute. And of course, we operate the hosted service that provides all of the management, reliability, orchestration, heuristics-based optimization, and we're able to provide a lot of value at that layer, leveraging this architecture. It's fully distributed, so none of this will work without a good security model, and that's sort of the Globus auth layer. So it uses an OAuth and OIDC-based security that really pulls all of this together, providing fine-grained authorization, delegation models, and such, right? So this model and this architecture has allowed us to scale really well. And so here are just some numbers. So definitely connected storage system. That's the first thing that was made available. So we have over 60,000 of those, but we're also seeing uptick. Compute tasks. We have over 33 million compute tasks that have gone through the system. You heard Ada, if you were here in the morning, you heard a tutorial about flows. We have about 240,000 of those that have run through the system. And we also have a search service, and we have close to about 200 million documents indexed through the search service, right? So this model has allowed us to really scale through all of that. And it's very gratifying for us to see new users come on board. So this is a graph for the last 5 years. Every month, number of new users logging onto the Globus service, right? So people are seeing value, and more researchers are coming onto the service and using it as well. So I'm going to start with the data ecosystem and provide you a little bit of an update, talk about that, and then move through the different parts of the product. So the fundamental level, like I mentioned, the agent model works here as well. So you have all these different storage resources, and they could be of different types. We have support for various connectors, whether it's cloud-provided storage, tape archive, object store. And Globus Connect Server is the software that essentially makes that pluggable into the Globus ecosystem. When the institution runs Globus Connect Server and connects their storage system, they create what are called data collections. And these data collections provide a rich set of capabilities for the users. They turn their data system into web accessible system, so you can access every file, every folder there using HTTPS. You can use our powerful transfer service for secure managed data transfer, collaborative data sharing, so allowing external collaborators to have access to the data with the right permissions. Then also consistent user experience, whether you're accessing an object store or something that's on-prem, all of that is provided, right? The transfer service sees a pretty good set of adding new users. So the orange band that you see, which kind of looks red on the screen, but the band in the bottom are new users to the transfer service. But the interesting thing for me, the thing that I look for here is the blue. This is the repeat users, right? Users who are coming back and leveraging the service and making it a part of their research tool to be able to move data, share data, access data, and such. A big milestone for us, for those of you who've been part of this journey for a while, was retiring version 4 of Globus Connect Server. We don't, actually this was the cake topper at supercomputing. If you were there, we had a cake to celebrate the retirement. We don't do major version updates on the software that we distribute. We try to keep it backwards compatible. We know it is not easy for you to make major version update changes and break things. Globus Connect Server version 4 had served us for over a decade before we retired it. And we are very grateful for the community for working with us and making this transition. We did finally have to forcibly turn it off. We kept extending the time. So you can see where the graph turns off. January of this year, end of January, we turned it off. And now everybody has moved over to version 5, sorry. So that's the orange line on that graph. So it's nearly impossible for me to speak about all the work that goes into the system through the year. So I have some highlights sprinkled through my talk, right? So this is some of the updates from the data ecosystem. It's very interesting to see the kind of requests we see and what the sort of features we're working on. People have been running Globus for so many years now that there's a lot of feature requests coming through transitions. People have had server refreshes. They have had people transition. We have had people retire and talk to us about how to transfer knowledge skills and access permissions and such. So these first two bullets you see here are very much about that kind of management, right? I've been running this for a while. I have thousands of collections. Give me tools to manage them. How do I do life cycle around those? So we have put in a bunch of features for that, where you can look at what's your last use time, be able to delete some of those old collections, defunct ones that you're not using, and such. We started the IPv6 path last year. I think our federal friends were making sure we were on track. Yes. If somebody at ESNet is watching, they should let Eli Dart know. He was on our case for years. So now we are fully there. You can use the data ecosystem in an IPv6 only environment or dual stack. Right? So all that support is out there. And then we continue to expand the distributions we support. So with new Linux distributions that come out, right now we have 26 versions of GCS binaries out there to support a wide variety of distributions. And we also added support for the ARM architecture for Globus Connect Personal. Right? Just a few things that were done there. A big part of the value proposition with Globus is the consistent user experience across different connector types. And we have added to that as well. So we've added Dropbox last year as one more connector that is supported. So you can use all of the transfer sharing features that I mentioned earlier with any of these, including Dropbox now. Right? I always add a slide on connectors because they are almost their own mini product. Each one of the connectors goes through its own evolution, right? The product is evolving, new features are coming out, and we are putting an effort to keep up with those. So pretty much every connector gets care and feed through to make sure we are keeping up to date with the functionality. So we've had some updates to OneDrive to use their preferred metadata to make it a little bit more efficient. We have had some HPSS updates in terms of error reporting. Google Drive is interesting. Google Drive supports the ability for you to have files with the same name, and then you have people transferring that data into a POSIX file system where you really can't do that. So we've had some handling, error handling and management. So we've added the ability for you to say, skip those and give me a list of those files that you skipped so that people can go back and reconcile that, right? For some of the other cloud connectors, we have added support to use personal accounts. Some of the institutions want to allow their users to come in and use their accounts and access data. And then the last one, we have a pretty significant partner ecosystem with storage connectors, storage vendors, especially ones that are AWS S3 compliant. So we just added another one last year, Storj. They're also sponsoring GlobusWorld this year, and I think those who were here saw their video in the morning. So there are vendors that have AWS S3 compatible APIs. They can work with Globus. We test it out, and then we have a partnership with them providing that to the user community. I'm going to move to another part, which is the protected data management piece. So I think everybody in the community is thinking about it in one shape or form. We are seeing a lot of our customers either setting up secure enclaves or looking at systems that they have today and how to support protected data on those systems as well. And we are seeing a big uptick. So this graph shows you monthly active use of high assurance collections. That means at least some data was moved on those. The ones in blue are people accessing their own data. The ones in orange is where they have shared data out with collaborators, right? So certainly you can see secure data sharing really plays a big role for us, and there's a good uptick of usage there. We have added support for timers with protected data. So timers is a product in Globus where you can come in and set either recurring transfers or scheduled transfers. And that was available for standard collections before, and we've just added support with protected data as well. And we also added lifecycle for permissions. So administrators can now set policies on how long permissions that you set on this protected data is available, and it automatically gets deleted once that threshold is hit, right? So these were things that were motivated by conversations with all of you where you wanted more administrative controls around these. And I think this is going to be pretty useful in meeting some of your security controls as well. Closely related to high assurance is the whole compliance space. So it's been about 7 years now since we started offering Globus for protected data, and specifically with for HIPAA-regulated environments. So you can use Globus for PHI, and you sign a business associate agreement with the University of Chicago. So you've steadily seen growth in the number of institutions who are subscribing to that level and using Globus in those environments. But along with that, we are steadily seeing increase in information security requirements, privacy requirements that are being imposed on us as well. So we're trying to keep up. This year, we have partnered with Indiana University's Center for Applied Cybersecurity Research. They are helping us with the compliance piece as well, keeping that. It's an ongoing effort, so they're helping us with that. But we do understand we need sustained resource there, and we are hiring. So I'll unabashedly put a plug here. If you know anyone who is in this compliance space and would like to come and join our team, there's a role that was just opened 2 weeks ago for leading our compliance program. Okay, switching to the compute ecosystem. So this was, for those of you who were with us the last few years, you heard announcements about, this came out of an NSF-funded project called FunkX, and it was transitioned to the Globus platform. And it has since been integrated into our platform, and more features have been added. So the compute ecosystem, very similar model. Institutions can take their compute resources that they operate or they manage and install this Globus Connect, Globus Compute Agent. And that essentially exposes their compute system into the Globus ecosystem as a compute endpoint, right? Again, the agent essentially abstracts a lot of the complexities of various schedulers. So if different types of, it has plugins for different types of schedulers. Somebody was asking me during the break about Kubernetes. That's supported on this as well. So the compute endpoint then provides a programmatic access into those resources. The cloud-hosted service that we operate is then able to provide value-added services, right? We are able to provide reliable and managed execution. A user is able to come in and ask for a task to be submitted, task to be run, and then it can be run on any of the resources that are connected through the ecosystem that they have access to and they have allocation to. Right? Also, again, provides a consistent user experience. You don't have to worry about the specifics of the various systems. You can choose the specific kind of resource that you want for your computation. It uses very similar security model as the data side, so fine-grained access control and such, right? I'll just walk through a quick schematic. So the big blue in the middle is us running the compute service in the cloud. And you have compute resources that are managed by the institutions. So the A and B there are completely distinct institutions. They all run compute agent that then connects their resource into the Globus service. So a researcher can request for a function to be executed. This uses a function as a service paradigm, so it's Python functions that you're executing. So you can go to the compute service and say, run this function for me in these 2 endpoints. And it's fire and forget at that point. The compute service manages the execution on these endpoints and then either stores the results or returns the results to the user, right? Again, Globus is not providing the compute resource, and the user must have the allocation and must have permission to run on those resources. So a lot of the users, actually staying on the slide for a second, the model we have today here is that the user has to run that compute agent, and then they use that to submit data. For those of you who are familiar with our data ecosystem, it's the equivalent of Globus Connect Personal, right? You run your own endpoint, and you're able to access it just for yourself. So we obviously see the value in making it available to the users. So Globus Compute Multi-User Endpoint is being released today, or was released on Friday. What this lets you do is, as an administrator, you can deploy this endpoint for your users and then set policies on who's allowed to run on this, what authentication is needed, what authorization is needed, and your users can come in and access this endpoint and run the jobs. It also allows the administrators to have pre-configured templates, so you can abstract out some of the details of your scheduler, so users don't have to worry about those, right? You can decide, queue depth, but you can do pre-configured templates. I'll leave it at that. And also policies. So maybe you want to restrict what user can run what. You could put all of those in there. I'm going to do a very quick architecture diagram here. So you have the user who wants to run a function and accesses the compute service. The compute service then talks to the multi-user endpoint that is run by the system administrator, right? It uses the same authentication and authorization we use everywhere else in Globus. So the user authenticates with an identity that you ask. So you can set domain-based policy on what domain authentication is required. And then it uses an identity mapping module to say what local account that user should be mapped as. That has two functions. It's an authorization step. If the identity mapping module does not map me to a local account, then I can't do anything. So it's an authorization step. Also gives us the local user account to act as, and it launches a process that then interacts with the scheduler and runs job as the user, right? So privilege drop happens there, and the process runs as that local user, and we do this for n number of users, right? So it's a very, very similar model to Globus Connect Server that's happening here as well. And in fact, both systems share the same identity mapping module code. So we have if you write policy in one place, you can apply it in both your deployments. So I'm not going to provide more details, but tomorrow there is a tutorial that Josh Bryan is leading. Tomorrow afternoon, he'll talk about this in detail and walk you through configuration setup and such, and you'll learn a lot more there as well. So the third aspect in the Globus ecosystem is the automation piece. For those of you who were there this morning, you heard a nice introduction to it. But at a very high level, the idea here is that we provide a reliable and managed task orchestration, right? You have all these resources, instruments, storage, compute, external services. We always take DataSite as a good example of such an external service that you may want to bring into your workflow. Or you can imagine it's the OSTI PID service, right? The DOE run PID service, so what have you. What the flow service lets you do is define these task pipelines that leverage all of these pieces. And we use an abstraction model there as well, so that you can call out to all of these pieces from the flow. So flow is defined by the user, and it's written in a declarative language, and every step of the flow can call any external service. We offer a whole bunch of external services, but you can write your own and have that be called out from the flow service itself, right? Globus provides the reliable, managed running of that flow service. So you write the flow, you deploy it to the Globus service, and then Globus service manages the execution, error handling. It worries about all the security. So we are calling out to external services. So we need fine-grained delegation of permissions and scopes. All of that is managed by the service, and delivers an event-driven model, right? So you can trigger this based on some events that are happening and run it, and allows the invocation of all of these actions. We are seeing a really good interest in this, especially in the instrument workspace. We're going to talk more about it tomorrow on how it's being used there and how you can put it together for complete automation. But it's a very general service. So we're also seeing it, for example, the materials data facility is using it for a data publication workflow, where when a data is submitted, they run through a full task or run through a flow that has steps for curation, metadata validation, and such, right? So you can do a lot with this. So we've been working on many facets on the flow service, a lot of it around providing better user experience for people who are running flows, so helping them with consents and authentication errors. So in the morning, there was a question through the flow, if I call a transfer, what happens if with authorization on the transfer and such? And the answer we gave was flow is really a client to the transfer service, right? So you might get errors back, or you might get additional authentication requirements back from the downstream services. So handling all of that has been added.
We've also made some improvements to what we call a guided start, which is how our web app provides a page for a user to fill in a web form and start flows. If you're not trying to do this from the command line, it's a really handy feature. It reads the schema of the flow and then provides a nice form that allows the user to start these things. And as of today, I guess, we have released a command and we have released a functionality for in-depth validation of the flow definition. So when you write these flows that have many states, it's almost like defining a state machine. You're referencing input parameters from different locations. You have schema that you're referencing. So we're trying to provide tools to make it easier for you to author them, find errors early. So this is a new command that has been added to our CLI that gives you a little bit more in-depth validation of the flow definition and provides you feedback before you deploy the flow into the system itself. Talking about our CLI and SDK, so we have a Python CLI and SDK have been around from the very, very beginning, and the enhancements to that almost always follows the services. Anything we add on the services, we come back and add options on the CLI and SDK. You can go look at the changelog. There is a ton of updates. On the SDK, there is also ongoing work to improve some of the ergonomics for people who are directly integrating with the SDK, especially around token handling, right? So you should see some releases on that coming out pretty shortly. Last year, we released a JavaScript SDK for Globus. I think probably one of the most asked things in the tutorials that we run. A lot of people have asked us as they integrate Globus into portals and such. A JavaScript SDK comes very handy. It has support for all of our platform services, transfer, auth. If you're integrating flows, you can put all of those in. And one of the things that we decided from the beginning was that the Globus web app, the one that we ship, will use the JavaScript SDK itself, right? So you could not get a better place to road test this thing. We have hundreds of users hit that web app. So the SDK gets tested almost daily. So functionality will be added to it. Will continue to get added to this the SDK piece, and the plan is to also build solutions on top of it. So we're looking at user interface components, so you can potentially embed some UI components in your portal rather than build out the front end pieces as well. So there's a lot of that's the direction we are taking with those libraries. There is a webinar next week. On May 15th, where Joe Bordigliero, who runs the web app team for us, is going to describe this and provide more details on that as well. So that's a roundup of various parts of the product, very, very high level, just touching on some of these things. I want to switch focus and talk a little bit of looking ahead, so what's coming. And we use what we're hearing in the community, what feedback we are hearing from you, where we see Globus being deployed, what kinds of questions are coming through support. So I have a summary. This is surely an incomplete list, but a list that we are paying a lot of attention to, right? So lots of conversations around secure data distribution, publication is happening within the community. Some of it definitely by mandates that are coming from federal agencies on making data available. There is discussion around how institutions will provide support for it. What do institutions provide? What are researchers responsible for? How do you make it easy for them to publish data? And how do you integrate with existing solutions, right? So that's a big set of conversation. A lot of it is also platform conversation. So they are trying to use our APIs to integrate into these things. Fair data. For those of you who are not familiar with the acronym, it's findable, accessible, interoperable, reusable data. And I think NIH is probably pioneered that term, but it's widely used now. And we also hear a lot of ML-ready data, machine learning-ready data, right? But ultimately, this is metadata capture, data organization for researchers, and how do we do that earlier and earlier in the life cycle so it can be made available. We were just at a conference 2 weeks ago, and I was at a Fair Data Symposium. And one of the things we talked about there, and one of the things I presented, was a phrase that Ian put forth, which is fair by default. can we give researchers tools so that very early in the life cycle, they are thinking about how to make their data ready for this, rather than think about publication at the very end, right? So this is also a conversation we are having a lot with our users. The third bullet there is migration across storage systems. I should probably rename this as the hunt for low-cost storage continues. That's been the driver for this for years. Google Drive, Box, now back to a lot of on-prem. People who are Microsoft shops are doing OneDrive. So, I mean, that pretty much drove that logo slide that you see of all the connectors. If you see the progression, you can see that's been the driver for us as well. So a lot of universities are looking at that. Enterprise is looking at how to support it, and Globus is being used as one of the tools for that. And it's not the same as an end user moving. So we are also seeing feature requests come through that piece. Instrument data handling, that's been a big focus for us. That's been a lot of conversations with core centers, RCCs who are supporting their core centers with that. And then the next two are more compute related. So there's a lot of conversations about how do researchers find the right resource to compute on, right? If they're running a particular kind of model, if they're running a particular kind of application, how can they discover them and run them without having to fundamentally change all the client-side tooling that they're doing? And then similarly, compute campaigns. So here is a bag of tasks, and this is the conditions that I want. Go run it, and then come back and tell me what the status is, right? Sort of that kind of discussions. And then the last one is making all of this accessible. So we're talking about a lot of powerful functionality here and trying to lower the barrier for adoption, which means everybody now is investing in portals, science gateways, Jupyter notebooks, paths to give access to these things. And that also drives a whole bunch of interesting asks of us. In that case, it's not so much that Globus is software as a service, but that we also offer all of this as platform as a service, so you can integrate this in. So what are some of our focus areas? I'm sure we are going to talk about this in more detail on Thursday for those of you who will be at the customer forum, but I wanted to highlight some of these pieces, right? So the first two are on the data side. I just talked about a big change from Globus Connect 4 to version 5. It was not only a major version change of what we distribute, it was also an architecture change, a terminology change, which is always fun. Things got renamed. So we're talking about harmonizing all of it. We have done some work towards it. The UI has been updated and such, but we're also looking at our APIs. We haven't had the transfer API has remained backwards compatible since beginning of time, and that means there's a lot of baggage in that API. So we are rethinking what that would look like, and how do we make it easy for what should the new API look like, and how do we make it easy for connections there. Connector enhancements, that'll certainly continue. We are having conversations with a couple of groups who run HPSS about supporting optimizations there in terms of doing large batch transfers. We are also looking at Google Drive enhancements. There has been requests for being able to handle Google native files. So for example, if you have a Google Doc or a Google Sheet and you do a transfer, today when you transfer, it just moves the GDoc, which is just a pointer to the file in Google, but you can export it in different formats. So every connector has a litany of these things, but here are a couple of highlights that we will be spending time on. Third one is interesting. Automation is picked up. A lot of people are both using flows, but also just even using our CLI SDK. You could do a lot of powerful automation. So we are getting asked a lot of questions around increasing limits. They want to run more transfers for a single account, or they want to be able to have more guest collections and such. So we are reviewing the system to figure out how we can increase the limits. We do increase them based on use cases and have discussions. But overall, how do we expand the system and provide a little bit more capacity there for everybody? The compute team is working on MPI support, which I'm told will be released soon. So that should come. I know there are some people who are waiting on that. But on the compute side, certainly the multi-user compute endpoint is big. It was just released. We are already working with some groups. You will actually hear a presentation from one group who is already using it. We are working with some other groups on deployment and getting feedback, and hopefully you will all walk away from the tutorial tomorrow and deploy it at your institutions. We are focused very much on the web interfaces as well, right? How do we provide interfaces for both the administrators to come in and be able to see what is being run and how it is managed? So if you're using the console today, what does console for compute look like? And then from a user perspective, today when you submit tasks to compute, it's typically a Python client, or that's sort of what people use. How can we come in and provide that, again, lower the barrier? Can we provide a web interface where people can put in a function and be able to run it, right? That's going to be a pretty big area of focus for us in providing pieces there. The search service, Globus has a hosted search service. It's self-service index creation and management, so you can come in and create a search index and put metadata of your choice. You can define the schema and such. So we've seen some good usage of the service, and now particularly we have two projects. One is the Earth System Grid Federation project, and the other one is USGS. You'll hear about USGS tomorrow morning. They are two engagements that we have, funded engagements through our professional services team, which are driving a lot more features into the search product. So you're going to see more work done in terms of providing more fine-grained management of the search index and even the data that is in the search index. How do you provide authorization and access control for who can update it and such? So we expect quite a bit of work to happen on the search space. We're also looking at other interfaces for the search service. So for example, the geo community has standard APIs that they use, supporting some of those as another way to come in and use our search service. Now, last bullet I have there is adding to our high assurance tier. So continuing to add more features into the protected data. This morning, someone asked Ada about using flows with protected data. We don't support that today, but that's something pretty high in the list. Same thing with compute and other pieces. So the idea is we try to bring all our services into the high assurance tier. So again, just a highlight of some of the things we're looking at, and we can certainly have a more detailed discussion on Thursday at the customer forum. I want to delve into two things before I close out here. On the flow side, we are looking at, we have made it pretty easy for you to come run the flows, be able to manage flows that are run, and we are paying a lot of attention to authoring flows. This is quite washed out. But if you really could read hard, what you see here is actually a flow definition. What we're working on is more like an IDE to be able to come in and support people who are authoring new flows, to do automatic schema validation, be able to visualize the flow so you can catch where the errors are or what unreachable states, but also integrate in with the action provider schema. So if you're using a particular action provider in your flow, we already know what shape and form your definition should take. So we'll be able to provide better feedback to you on those, right? And also the validation tools. So I talked about these in-depth validation tools that have been built that are now available via the CLI. How do we incorporate some of these things to really lower the barrier for adopting, for essentially authoring flows and making it available? And then the last bit I'll talk about is portals, everybody's favorite topic. So I'm sure all of you are running or thinking about running portals because it provides these really easy, it provides a much simplified interface for users to access pretty powerful capabilities, right? So Globus is extensively used. We know there are a lot of portal deployments out there that is using just Globus Transfer. They don't necessarily use our web app. They are calling Globus Transfer from their portal, or Globus Auth to provide federated authentication. There are many levels you can come in and integrate, right? To first order, there are open APIs. So whatever portal you're writing, you could directly integrate with our REST APIs and use that. The SDKs that I talked about, the Python SDK, the JavaScript SDK. We also have something called helper pages. These are web pages that we host that have specific functionality, for example, to come and choose a collection to submit a transfer to. And it's almost treated as an API. So it has specific query parameters you can pass in, and it returns query parameters to you. We also have the sample portal, a Python-based portal that was written a long time ago. And it was released and it was written mainly as a sample portal and as an educational tool, but I think it's being run in production in many places today. You can, if you like Flask and Ginger templates, it does fine, and you can use that as well. About a few years ago, probably 3 years now, we also released the Globus Django portal framework. So if you are in the Django ecosystem and you have portals and that's what you build, then we have a portal framework that really gives you a leg up. It already has the pieces that you need for integrating with Globus for authentication, data access and transfer, and for search, right? Now we are working on, and we have early release or early beta release of a Globus static portal framework, right? In the Django case and the Python case, you are actually running server infrastructure where you're hosting the portal. The static portal framework essentially lets you create single-page applications. So these are things that you just distribute, and the application itself runs on a user's browser. Right? A lot more flexible, no infrastructure on your side. The way we are doing this is we are providing, going for a no-code solution here. So Globus provides these generators, and that for common use cases, right? So we have a couple out there today. One that lets you say, I want to run a portal which is distributing data from this guest collection, right? And all the, to stand up a portal, you are customizing the configuration. You're telling us which collection ID, which path you want to distribute. And after that, the generator code automatically generates the static pages that are needed, and you can host them from any location of your choice. This could be GitHub pages. This could be an S3 bucket that you're putting it in. It could be from your on-prem servers. And the generators and the infrastructure around it also includes continuous CI/CD. So we have integrations with GitHub Actions, for example, so that it can automatically push these out, right? So just to make this a little bit more concrete, I'm going to go through a few screenshots, right? So first, you register your portal with Globus. There's no getting around that. Every application in the Globus ecosystem needs its own credentials. So you register that, it gets a client ID and a secret. That's how the portal authenticates to the Globus ecosystem. Then we have published a bunch of template repositories in Globus, in the Globus GitHub. If you go to the Globus organization in GitHub, you can see those. So you create your repository from the template repository. So I've created mine here so that you can use this template and create your own, create a copy there. And then you make some changes. The template repository already is configured with GitHub Actions and Dependabot so that it can do all of the CI/CD and the dependency management, right? So then I have to configure my repository to allow GitHub Actions, GitHub pages, so that because I want to host this on GitHub pages. And then the one thing I update is the configuration. I want my portal to serve data from this particular collection and this path, right? So I can update the configuration. In this example, it's just those two things. But you can imagine portals. We have another one where you update the search index. Which search index do you want to, the user to search from? What facets do you want them to use and such? And that's it. GitHub action fires. The portal gets deployed. It is using GitHub pages for the portal. And it is also kept updated because we have the dependency management, right? So what we're really trying to do is eliminate infrastructure on your site. So you have, whether you are a research lab which is trying to stand up a front end and distribute the data or provide a discovery on your data, or you're an RCC center who is trying to serve people, PIs at your center who want to be able to stand up this infrastructure, you can do this without really standing up any servers on your site, right? So once you create a copy of your repository from the template repositories, of course yours, and you're welcome to customize it as much as possible. We are providing some templates so you can make the simple cases simple, right? So press a button and it happens, and then you can customize it as well. So this is really, really new. Work has been happening recently on this one, and we have a couple of generators out there that you can go try, and you're going to see more of this, more work in this space come out. So last part of the presentation, last but the most important part. So we deeply worry about how we sustain and grow Globus. I think all of you are aware we have a annual subscription-based model for sustaining the Globus operations and the Globus product itself. And it's been fantastic. We have seen pretty steady growth in subscribers through the years. So we're very grateful for all of you. who are subscribers and supporters in this work. So this is the last 5 years. And you're seeing the blue are existing subscribers. So we have pretty good retention rates for people who are subscribing. They find value in it and come back every year. And then that's the orange is the new subscribers in there. Our FY closes in June. So that's almost complete for this year. On this side, it's the breakup of the subscribers by type. The large swath, more than 50%, just about 50% are standard subscribers. So they are not using protected data. They're using standard subscriptions. All these subscriptions are unlimited use. So it's enterprise-wide, unlimited data, unlimited users. They're using standard subscription there. The 19% that you see there in orange are people with business associate agreements with UChicago, so they can use it for HIPAA-regulated data. The other 19% in blue are high assurance, so that is additional protections, but more for CUI or PII data. And then we have some starter subscriptions and some custom ones for projects. We also do that, right? So we've been seeing really great growth in this area. We are very fortunate on the retention as well. So people are finding value in the new services that we are providing and continue to come back for this subscription, annual subscription. Given the growth, we are at about close to 250 organizations. We had to move away from Greg setting up everybody's subscriptions and our support team doing that to a process that scales so he can do something else more useful. So we have a self-managed subscription now. We are leveraging our own group service for it. So if you are a subscription manager, if you go to the settings page, you will see, actually all of you can go to the settings page, you will see a subscription tab. What this allows subscription managers to do is manage who gets access to these things and policies at their institution. And for users, you can go discover if your institution has a subscription and then request for joining these groups and get access to various things. As a user of one of these groups, you have access to premium features deployed at your institution, right? The policy, who can get access to it and such, we have happily handed it back to the institutions, right? The institution configures this, they decide. We have everything from where everybody can join to where emails are sent and it's authorized and such. The one plug for Greg, when we made the transition, we put a wall of text as your group description for all subscription managers that was meant to provoke some, uncomfortable feeling and edits. But you know how defaults stick, right? So the defaults are stuck, and it's been months, and we have walls of text. So if you are a subscription manager, please take a couple of minutes and edit that text to say something to your users on who they may contact if they need help or anything. There's a whole page of text, and that was done by design. So.
Is Greg at globus.org okay?
Absolutely. Go for it, Charlie. Okay. So, like I've started this one, it is really awesome to see so many of you here investing time with us and engaging with us. We have a great partnership with all our users and customers, and it really gives us a lot of energy when we meet all of you and learn about how you're using things or what we could be doing better. Throughout the year, there are many ways to engage with our team. There is the Globus support team. You can certainly email Globus support or our help desk. But also, we have newsletters that go out with interesting information, upcoming events, blogs, and such. If you haven't subscribed, please do. We run office hours maybe once a month now, give or take. Some of them are thematic. Some of them are just open. And it is staffed by, you can come in and bring your questions and have live answers. We put all of our engineering team on notice during that time. So if we are not able to answer, we can ping them on Slack and get them to come and answer questions for you. So it's a valuable resource to get your questions answered. We also have a Globus Discuss mailing list. It's more a community list. I know several of you also help answer questions there. People post their experiences and ask questions about it, and we do our best to staff that as well. So I encourage you to please connect with us and engage. We learn a lot from the questions you post there or things that you send, and use that to drive our product as well. As a part of that engagement, Vitas, who is our user experience manager, who's sitting here in the corner, he is running a usability testing. So if if you can spend 20 minutes, please sign up, and you can give him all your critical comments about the UX. So that goes there. So that's vitas@globus.org, Charlie. If you want to send that one there. Okay. With that, I'm going to turn it over to Ian. All of this is in service of science, and Ian is going to tell us some about impact and science use cases. Thank you.
Hey, it's great to see so many people here. And what I'd like to start off just by saying, well, I'm so grateful, and I hope you are, for the amazing work that Rachana does and the whole Globus team. So thank you very much for your work. So I'm going to say a bit about some interesting science directions that I'm just going to talk briefly, so don't worry. I've got so start off explaining why am I, so you heard about automation, and in a way I think what Globus more than anything is a automation platform for science. It provides, as we've heard, this powerful set of APIs that allow us to do more and more things in a globally distributed environment. So why is that important? Of course, it's important for doing important but mundane things, but I think it's also increasingly important to undertake a new sort of science that we're seeing becoming increasingly important. And this is a slide I borrowed and adapted from someone else, but I think it captures some of what we're seeing. So it's always nice to refer back to is that Plato or Socrates or Aristotle? I forget, but someone will recognize him. Going back to, to the early days of science, of course, many of us lived through the beginning of what we call the data-driven fourth paradigm of science, in which large amounts of data were being processed to make sense of systems that we couldn't previously understand. But increasingly, as the cycles increase in scale, complexity, and speed, we see ourselves moving towards a mode of accelerated discovery, in which we are seeking not simply to sit in our labs. Scientists, thinking about as a scientist here, sit in our labs, conduct experiments, publish results, read what other people publish and other results, but to automate this entire process by which hypotheses perhaps are no longer generated by humans but by computers. The research protocols we use to evaluate hypotheses, to test hypotheses, are not generated solely by humans, but it may also be generated by computers, and so on and so forth. And expanding on that little cycle here, this is what certainly myself and my colleagues at Argonne and many collaborators are engaged in, is working out how can we accelerate the discovery process in a whole range of fields by using a combination of things. AI increasingly to do things like make sense of large amounts of data, generate hypotheses, interpret the literature, plan experiments. High performance computing, often to validate ideas via the purpose of simulation, and increasingly often also robotics to perform experiments, physical experiments to test hypotheses. So we're certainly not the only ones undertaking these, seeking to realize this new approach to accelerated science, but we have some benefits working at the University of Chicago and Argonne, and hopefully you will also be able to seize these benefits too, because in order to realize this goal of AI, HPC, and robotic accelerated science, we need to be able to access and integrate data anywhere, computing anywhere, scientific instruments anywhere, a growing number of services anywhere, and we need to be able to do this securely, reliably, rapidly, and scalably. And that's what the Globus platform lets us do. And that's why I'm certainly so excited about where we are at the moment with the capabilities we've provided. And you can see I put a Globus Flows logo in the middle of this little cycle, because increasingly we see flows being used to drive these virtuous cycles of by which as it's worth reading out some of these things. We extract knowledge from the scientific literature or from scientific databases. Based on extracted knowledge, we generate hypotheses using generative AI models. Once we have a hypothesis, we may generate an experimental protocol in a similar manner, perhaps extracting it from the literature and specializing it for our available equipment. And then we use robotic labs to actually execute those protocols, and so on and so forth. So now let me talk about a few things that we and many colleagues are involved in that speak to some aspects of this overall cycle. So one thing I mentioned a couple of times is generative AI. Which we see as increasingly important for making sense of large amounts of data and for helping us to understand the implications of that data. So one project that we're involved in, many others here I think are also involved in, is the construction of open source, open science foundation models. Models like ChatGPT, but trained on large amounts of not just regular web content, but scientific literature, scientific data of different sorts, and suitable for fine-tuning and other forms of specialization for a variety of downstream scientific tasks. Hypothesis extraction, inverse design, code generation, and so on and so forth. We've established an international consortium called the Trillion Parameter Consortium that is in pursuing the construction of these foundation models. In fact, we have a meeting in a few weeks, I guess, in Barcelona to discuss next steps there. But at Argonne itself, in partnership with collaborators, we're engaged in a project called Aurora GPT, which is seeking to build such a foundation model for open science, a general purpose scientific large language model trained on a variety of data sources. So you might say, what has this got to do with Globus? Well, actually I've got a couple of Globus logos here. In one sense, it doesn't have too much to do with it, except this is the engine that's powering increasingly the cycle I've talked about. The people constructing the model are using Globus to move the data that is used to train the model. People who are building the inference pipelines that allow people to run the model millions of times, perhaps, are using Globus Compute to access the compute resources. So it turns out if you want to build an ecosystem of foundation model technologies for science, you need a lot of machinery, and Globus is good for providing that. Okay, so we've got the foundation model that we can use to implement various parts of this AI-driven cycle. Increasingly, what we see, though, is people are not building individual models, building a single model for everything, but hybrid models which use a technology called community of experts to link a general purpose foundation model with various domain-specific models, perhaps coordinated by some sort of user experience model that can decide what to do with each user request, whether it's for a hypothesis or for something else. And this is something that we are engaged in constructing using some of these Globus technologies. So let me give you a quick example here. And sorry, there's a bit of some overlaps here due to, but that's okay, we can cope. So here's some work being undertaken by a student called Priyanka Sethi at the University of Chicago, along with Arvind Ramanathan and others. Let's say as part of your ecosystem of AI models, you want one that can tell you about a particular type of biological construct called a peptide. And actually that's something that it's fairly easy to build. You build a system that might retrieve abstracts from PubMed that reference a peptide and then ask ChatGPT or perhaps Aurora GPT to use retrieval augmented generation to provide information about that peptide. So that's a little agent that you can construct and deploy on computers using Globus Compute. And of course what we want is the ability to be able to run millions of such requests, as scientists they usually aren't interested in just one peptide. They want to know about millions of them so they can find out the best one for such purposes. And then once they've done that, they then want to be able to do things like take the peptides they've identified, invoke high-performance computing to decide whether or not their structure is suitable for an intended purpose, perhaps running on HPC systems, and then deploy experiments in self-driving labs to verify whether or not a particular peptide is suitable for its intended function, which might be, for example, to destroy a particular or interfere with the function of a particular microbe. So that's the sort of system we see people building with the technologies that we're describing here. And to give an example of what that looks like in practice, these are some of the autonomous research labs being deployed at Argonne. This one has even got a little video in it, which you can probably see some of. Each of these is a self-driving lab specialized for a different set of applications. Okay, so, and as I show here, each of these, of course, has got Globus transfer, Globus Connect servers deployed on it so that it can integrate data produced during experiments with data stores, and also uses APIs to dispatch computing requests to computers both within and outside the campus. Okay, so that's just to wrap up. Automation is of course important for lots of things. One thing it's important for is allowing us to do things that are otherwise too boring to do on a routine basis, but it's also important as a way of enabling new approaches to scientific research, in which, as I show here, we run these virtuous cycles where discoveries are pursued by quasi-independent agents, presumably, usually under careful human supervision and control, but performing things that could not otherwise be done by any single human due to the lack of time and resources. And to make these things work, we need the services that Rachna and others have been telling you about. So thank you very much. How are we doing for any questions? Yes, questions, comments? Yes.
As science gets more expensive, teams get bigger. In my own career, I started off in an experiment where 300 was huge. Actually, it was 50, and then I went to a bigger experiment. We're now dealing with teams of 3,000. When you have a big team, you often have a distributed computing infrastructure that's well established. Has Globus thought how to better integrate with some of that ecosystem, so it's not an either or, but an and?
Yeah, so science, of course, is team-based, and I think a lot of the motivation for Globus is the functioning of teams of different scales. Teams that might link, multiple universities in a lab, and they need to share data, computing, and other resources. I think you may be referring in particular to the high energy physics community, which has, which has for many years, of course, built their own almost parallel universe of often very nice technologies. I think it would be great for us to work more closely with them. So far, we haven't had so much success, but I see the approach to working with them is to build bridges. So Globus endpoints can be deployed in their labs. We can build connections from Globus Compute to their high energy physics, high throughput computing clusters, and so forth. So we would love to talk about how best to do that. Yeah.
What kind of adoption have you seen for HTTPS now that GCS5 is the standard? Do you have any metrics on how much data is being accessed over HTTPS? Because I think that de facto standard for data movement, really when you talk about connecting with other communities, can have a huge difference.
Right. So the Globus servers now allow you to you can't do third-party transfers as far as I know, right? With HTTPS, but so the fundamental substrate of driving third-party transfers from one server to another is still very much based on the underlying grid FTP. Not that that is visible to you, but a server can allow people to download data with HTTPS, which is certainly a wonderful thing. And how much uses are we seeing?
So unfortunately, the model is that the data goes from the institution to the user. There's nothing that we are not involved in that transfer. So there's no way for us to gather metrics other than having sort of servers report up to us. Right?
Yeah.
Have metrics on which servers have it enabled and which ones don't?
All GCS5 servers have it unless explicitly disabled. But no, I don't have metrics. I think a lot of them have it available because the HTTPS access also does not imply the data is open. You still have to authenticate the authorized to access it. But unfortunately, we would love to get that metric. Thank you.
Yeah, so the comment was Rachna, just to make sure people are here, was if people retrieve data from a Globus Connect server using HTTPS, we don't see that download because it's a purely local action, and so we don't have statistics on how many such transfers are performed. It might be nice to make, if people are willing to add statistics
Usage
collection.
statistics server like
Yeah.
we've had before?
Yes, right. Yeah. Yeah.
Other questions, comments?
Well, thank you very
Okay.
much again for being
Thank you.
here, and I look forward to talking to many of you during the rest of the conference. So, thank you.
So one more thing to copy Vas's theme. So first, I would like to actually add to Jens's thanks. We have a fantastic team, very talented and dedicated people here at for the Globus team. They do really great work, and I'm very grateful for what they've done here. So thank you to many of them are here. Some of them are here, many of them not in this room, but a huge kudos. A lot of these things were done in time for GlobusWorld, but overall very dedicated to the mission, and it's a pleasure working with them. So thank you to the team there. I want to mention one thing. When I talked about engaging with us, I talked about this Discuss community list. So we have a Globus Discuss list. It's a community list. You can all post questions. We try to get most of the answers, but there are other people in the community who answer these questions for us as well. But there's one person we wanted to recognize for significant contribution on that community list, really stepping up and helping us on that list. I'd like to request Carl Cornell from Stanford University to come up, please. So Carl has been part of the Globus community for years. Carl, if you wouldn't mind making your way up here, we have something to give you while he's making his way up. Carl has been part of the Globus community for a number of years, and he proactively picks up so many questions on Discuss. He has deep expertise on installing, managing GCS. He picks up a lot of, and has helped many new users who come on and ask questions. When Carl files a bug, usually late Pacific time zone, right? That's when you get support tickets from him. You know it's well thought out of, it's really well researched, and you know you want to pay attention. There's something that in there. It's not going to be, oh, Carl, you missed this, because he would have gone through our documentation, tried out the N options, and given us what the choices are. And just even at Stanford, he has been instrumental in making sure there's wide adoption of Globus and use at Stanford, whether it's their enterprise computing or their core facility. They all go to him, and he maintains this really good website with information about it. So we are utterly grateful, and we just want to give you a small memento.
Thank you very much.